Again, this is more of just reviewing and making sure everybody's on the same page. So part A, or question A right here, is a rectangle. So we would be using base times height. And you know that I'm not a fan of fractions, so I'll turn everything into decimals because I just think it's easier, and that not everybody knows how to enter a fraction into a calculator correctly. So it's in your best interest to just turn those into decimals. This is inches, and we got inches squared. When you talk about area, you're talking about a two-dimensional figure. So if you're in 2 dimensions, that's why all of our answers are going to have this squared unit on it. When you talk about volume, which we will do later on when we do concrete, that's a 3-dimensional thing. So that's why it would be inches cubed for volume. But for right now, we're in a 2-dimensional space. Let's do another example here. We got this circle. That 6 3/8 is the diameter of the circle. We need to have the radius. So let's turn that fraction into a decimal first. And the radius would be half of it. So if we divide it by 2, that's our radius. And now our formula for area of a circle is pi r squared. There is a pi key on the calculator, but we are able to use 3.14 as an estimate for pi. .14 times 3.1857. Now, if you didn't have the exponent key on the calculator, or you weren't sure how to use it, you would just multiply by 3.1875 a second time. It's a trick. Our answer here is 31.903, and this would still be inches squared. Even though it's a circle, we're talking about area. Area is always inches squared. Okay. Let's do C. What you're going to have to do with C is break it into 2 sections. It doesn't matter how you break it. If we draw a straight line down through here, you've got 2 rectangles, right? But you just have to be careful that the height and the width of the section on the left is right there. Don't use that 9. So we're going to go 10 1/4 times 3 1/2. I got 35.875. And that gives me the area for this section right here. Okay, I need to do a little bit of calculating to get some measurements for the right hand piece. I know that it's 10 feet or 10 1/4 inches tall, but I know that this is 9 inches, so I should be able to find that little extra piece just by subtracting those 2. So this is 1 1/4 inches tall. As far as the width goes here, we've got 8 inches, but we also know this piece. So if we subtract 8 minus 3 1/2, I should get 4 1/2. And then I can plug that into the formula to get the area for that little section. I would then add these two pieces together. Now, if you worked it out and you worked it out the other way, your process is going to be different, but your answer, your final answer, should be the same. Let's look at D here. Do one more example together before we move on to our next assignment. So D is a rectangle down here on the bottom, and then this is a semicircle on the top. So let's look at the bottom first. The bottom's easy because it's a rectangle. We would just take the base times the height, but remember you got to turn that fraction, should turn that fraction into a decimal if you can. 9.875 times 4. And for the semicircle, we would use our area formula for a circle, but it's half of the circle, so we could just put a 1/2 in the front of it and handle all the calculations that way. So we've got 1/2, or I like to say 0.5, times pi. Now times the radius squared. Now that's a problem because this 6 is actually the whole way across the circle. That's the diameter. We need to know the radius. The radius would be 3 because it's half of it. And we're going to plop all that into our calculator. Then, because the two pieces are added together, we add those two parts together and we get 53.63 inches squared as our final answer. Now, if you say, I got a different answer, well, if you use the pi key on the calculator versus 3.14, you are going to get a different answer. But it should only be slightly different than what we've got together.